In example 52, we're going to just graph this system of linear inequalities, find the solution region of the plane, and we could start out by graphing the lines we get when we change, of course, these inequality signs. All of these are greater than or equal to signs to equal signs, and finding the intercepts. Now, because of the fact that they're written in this sort of standard form actually makes it pretty easy, and we can find these intercepts without doing a whole lot of work. You can go ahead and set up the equations you get when setting, each of the variables equal to 0 if you like. We can kind of figure it out by inspection. This first one, I'll number these 1, 2, 3. In the first one, if we set y equal to 0, we get an equation 5x equals 20, which means x has to be 4. And if we set x equal to 0, we get y equals 20. And the second one, if y is equal to 0, x is equal to 12. And if x is equal to 0, y is equal to 12. And for the third inequality, if y is equal to 0, x is equal to 18. And if x is equal to 0, 3y is equal to 18, which means y is equal to 6. We don't need to find intercepts for these last one. These are just the non-negative restrictions. And since both x and y are greater than or equal to 0, it tells us that the region is going to be in the first quadrant. So taking a look at our intercepts, looks like it would be a good idea to draw a scale so we can go up to 20 on each axis. Neither of the x or y intercepts goes above 20. So I'm going to go up by 2s. For the first equation, if we were to graph 5x plus y equals to 20, we're going to sketch or plot our intercepts. X-intercept is 4, y-intercept is 20. So I'm going to, just to help kind of keep this organized, I think I'm going to just label the line. That's for that first inequality. Now, as we go through this, I'll move the numbers over here. As we go through each one, we can see if testing 0, 0 makes it true. So if we plug in 0, 0 into the first inequality, we'll get 0 on the left-hand side. 0 greater than or equal to 20 is false, which means we're going to be shading the side that does not contain the origin. And for the second inequality, the second line has intercepts both equal to 12. And again, if we plug in 0, 0, the left-hand side becomes 0. 0 greater than or equal to 12 is false. And so we would, again, be shading up sort of above that line, the side that does not contain the origin. And for the third one, Our x-intercept is 18. Our y-intercept is 6. And again, if we plug in 0, 0, we get 0 greater than or equal to 18, which is false. So in all of these lines, we're sort of shading above them. Now, the other parts, these last two, the non-negative constraints that put us in the first quadrant here, we're going to take that into account because, of course, we have to be on this side of the x-axis, or sorry, the y-axis, and this side or above the x-axis. And so that means that our solution region is this sort of large unbounded region that we get that's sort of above all of those lines. So there's our solution region, and the only thing left to do is to find the corner points. And I always sketch before I think about finding intersections of these lines, and the reason is because not all intersections will be corner points. This is a corner point because it's a part of the boundary region. This intersection, though, is not. So we have boundary points there, and then we also have our boundary points here and here, where they intersect with the two axes. So I'm just going to label these as A, B, C, and D. Two of them are fairly easy to find, right? A and D should be easy to find because they're just the, we could tell by looking at our graph that boundary point A is the y-intercept for line number 1 here. So this corner point is 0, 20. And again, looking at D down here, that's the other one, the other intercept, and this is the x-intercept for line number, well, I didn't label that one, it's line number 3. So this is 18, oops, that's D, not B, 18, 0. So the only thing left to do is to find the corner points B and C. So by taking a look at our sketch here, I can tell that B is the intersection for lines 1 and 2. And C is the intersection for lines 2 and 3. So to find the corner point B, we're going to solve the system of equations we get just by using lines 1 and 2, those first two inequalities that will turn into equations. So 5x plus y equals 20. And x plus y equals 12. Now this is probably most easily solved by leaving the first equation unchanged, and I think I'll multiply the second one by -1. And when we add these together, we get 4x equals 8, or x equals 2. And now that we know the x-coordinate, we can find the y-coordinate. I think I'll use the second equation. That'll be a little bit easier. X plus y equals 12. Using x equals 2, we get 2 plus y equals 12, which means that y is 10. And so these are the coordinates for the corner point B here, 2, 10. And now we'll do the same thing to find corner point C. This time we're going to use lines 2 and 3. So x plus y equals 12, and x plus 3y equals 18. Again, I think I'll multiply x plus y equals 12, that one by -1, and leave the second one unchanged. Adding these together gives us 2y equals 6, and that means that y is equal to 3. And now we can find the x coordinate. I think again I'll use the x plus y equals 12 line. If we plug y equals 3 into that equation, we get x plus 3 equals 12, which means that x is equal to 9. So these are the coordinates for point C, 9, 3. So here's our solution region along with our corner points.